Assalamualaikum and good morning everyone. Today our group will be presenting on the Fukushima Daiichi nuclear disaster on 2011. Before we begin, let me introduce our team members. This presentation is prepared by Muhammad Asfar Firdaus, Muhammad Ali Husaini, Muhammad Harid Haikal, Muhammad Akif Fakrullah and Syed Zikri Iqbal. Together, we will be presenting the Fukushima Daiichi nuclear disaster and its relevance to the chemical health and safety management. General background of the accident. The accident occurred on 11 March 2011 at the Fukushima Daiichi nuclear power plant located in Okuma, Fukushima, Japan and was operated by Tokyo Electric Power Company or TEPCO. This disaster was not caused by human error alone but by a combination of extreme natural events, making it an important case study in chemical health and safety management. This accident considered as the worst nuclear accident since the Chernobyl disaster in 1986. The Fukushima accident was triggered by the Great East Japan earthquake, a powerful undersea earthquake with a magnitude of 9.0 which struck off the northeast coast of Honshu. Shortly after the earthquake, a massive tsunami with waves reaching between 10 to 40 meters hit the eastern coast of Japan. After the tsunami struck, it caused a complete loss of electrical power. The flooding disabled the external power supply and also damaged the emergency diesel generators, which were essential to keep the cooling system running. Without electricity, the cooling system could not function properly. This situation is known as a station blackout, which played a major role in the severity of the accidents. As the cooling failure continued, the fuel inside Unit 1, 2 and 3 overheated, leading to partial core meltdowns within the first few days. The extreme heat caused chemical reaction that produced hydrogen gas, which later accumulated inside the reactor buildings. This resulted in hydrogen explosion, especially in Unit 1 and 3, causing severe damage and releasing radioactive materials into the environment. In response, the Japanese government made the evacuation of over 100,000 residents and established exclusion zones around the plant. Due to the scale of radioactive release and environmental impact, the accident was classified as a level 7 major accident on the INES scales as the highest level of explosion. Next, I will pass to our next member to continue our next subtopic.
Let us continue with part B, the detail of the chemical and possible reaction that happened in the tragedy. First, we have the main material involved in Fukushima Daiichi accident was uranium dioxide, which was used as the nuclear fuel in the reactor core. Under normal condition, uranium dioxide undergoes controlled nuclear fission to produce heat for electricity generation. However, after the earthquake and tsunami in 2011, the power supply and cooling system failed. As a result, the reactor core was no longer properly cooled. This caused the temperature of the uranium fuel to rise rapidly, leading to fuel damage and partial core meltdown, which allowed radioactive materials to escape. Secondly, we have a critical chemical reaction occur between the zirconium alloy cladding of the fuel rod and steam. Zirconium is normally stable, but at extremely high temperatures, it reacts with water vapor. The chemical reaction can be written as zirconium react with steam to form zirconium oxide and hydrogen gas. This reaction significantly worsened the accident because it not only damaged the fuel rod further but also produced large amount of hydrogen gas, which is highly flammable. Finally, we have the accumulation of hydrogen gas led to a series of hydrogen explosions inside the reactor buildings. The hydrogen gas mixed with oxygen in the air and ignite, causing powerful explosion in several reactor units. This explosion destroyed the outer structures of the building and contributed to the release of radioactive substances into the environment, increasing both human and environmental exposure. In conclusion, the Fukushima Daiichi disaster was intensified by chemical reactions triggered by overheating, particularly the zirconium steam reaction and subsequent hydrogen explosion, showing how chemical process can escalate a nuclear accident.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Harid Haikal bin Wadi Alman. So I'm going to review about the properties, hazard, toxicity MSDS, Regulation and Safety Management Failure for the Fukushima Daiichi in 2011. The chemicals and radioactive materials that involved is iodine 131, cesium 134, cesium 137, strontium 19, and hydrogen gas. These substances were released due to loss of reactor cooling, leading to fuel overheating and partial cold meltdown. So next, I'm gonna review about the properties of hazardous substance. Iodine 131 in physical state is volatile radioactive isotopes. Half-life about 8 days, and the behavior is easily absorbed by the human thyroid. Environmental mobility high, airborne, and water soluble. Cesium 137 is in the physical state is radioactive metal salt, high soluble in water, half-life in 30 years, behavior mimics potassium accumulates in muscles and tissues. Environmental presents very high soil and marine contamination. Next is hydrogen gas. Physical state is colorless, odorless gas. Hazard is extremely flammable. Roll in accident, accumulate in reactor building and cause hydrogen explosion. Next, I'm going to talk about hazard and toxicity information. Health hazard. Radiation exposure can cause acute radiation sickness, high doses, increases cancer risk, thyroid cancer, leukemia, genetic damage. Iodine 131 especially increases risk of thyroid cancer, especially in children. Cesium isotope cause long-term whole body radiation exposure. So next is environmental hazard, long-term contamination of soil, groundwater, marine ecosystem. This can cause the disturbance to the food chain itself. So the bioaccumulation in fish and crops, large ecosystem zones established due to unsafe radiation levels. After that, I'm going to talk about the MSDS safety data sheet relevance. So the the key and radiative equivalent information includes radiation type, beta and gamma emitters, exposure routes, inhalation, ingestion, and skin contact. Protective measurement needs to radiation shielding, personal protective equipment (PPE), control access zone. Emergency procedures is evacuation, decontamination, administration of potassium iodide KI tablets. After that, I'm going to explain you about the regulation related to use and control. Relevant regulation include International Atomic Energy Agency IAEA safety standards, Japanese nuclear safety regulations, radiation dose limits workers and public, emergency preparedness and response protocols. At Fukushima, tsunami risk was underestimated, backup generators were not adequately protected, emergency response planning was insufficient for worst case scenarios. Failure in safety management is number one is poor risk assessment. Tsunami height and estimated were too low and historical data was ignored. Second is indicate emergency preparedness. Backup power system flooded and the cooling system failed completely. Third is design and engineering flaws. Hydrogen venting system were inefficient. Reactor building were not explosion proof. Number 4 is regulation oversight weakness, lack of strict enforcement, over relying on outdated safety assumptions. And the final one, delay decision making, late evacuation orders, slow information and disclosure. The final thing is the link to chemical health and safety management. Hazard identification must include worst case scenario. Safety system must be fail-safe and redundant. Emergency planning is critical. Strict regulation compliance is essential. Chemical and radiological hazard require eco-rego in safety measure. Thank you.
Today, I will be talking about impacts of accident on people's health and environment, and also lesson learned from the accident. The topic is Fukushima nuclear disaster. So, firstly, I will go for impacts on people's health. My first point is radiation exposure. As we know, when the disaster occurs, people will easily exposed to the radiation, and we need to find a solution to avoid it. So, at this time, most residents receive a low to moderate radiation doses due to evacuation and safety measures. Because of the action, there are no immediate radiation-related deaths were recorded, but workers at the plant face higher exposure and they need to apply emergency safety limits for their safety from hazard. My second point is long-term health effects. In this accident, thyroid cancer was concerned increased among children due to radioactive iodine. However, scientific studies show no clear widespread increase in cancer rates, but long-term monitoring must continue for the safety. In the same time, psychological stress, anxiety, and trauma were more severe than physical radiation effects due to the the accident. Secondly, I will talk about impacts on the environment. The first thing is marine ecosystem damage. When marine ecosystem damage occur, the radioactive water leaks into the Pacific Ocean, which show radioactive traces on fish and marine life, and affecting the fishing industry. When this happen, the population of fish and marine life will decreasing, and which threatening ocean health and stability. Because of this accident, it caused a long-term dilution to reduce risk. At the same time, public doesn't have any trust in seafood safety, and they take action to avoid eating seafood at that time to avoid a serious health risk. Secondly, is land and agriculture. When land and agriculture are disrupted, it will lead to farmland contamination, such as crop destruction and long-term bans on agricultural products. This will cause decrease in domestic production and reduce in investment. To solve the problem, you need to undergo extensive decontamination, which involve removing topsoil and vegetation. Lastly, it's about lesson learned from the Fukushima disaster. I learned three things, and my first point is importance of disaster preparedness. As we know, we need to prepare every time to preparation. We need to prepare every time because we don't know what might happen in the future. So at this, so my point is, an engineer must design a nuclear plants to withstand worst-case natural disasters, not just the predicted ones. Also, they need to build a backup power system that be protected from flooding, so that when flood occur, the power system still can be used. Second is the nuclear safety and regulation. After the accident, they need to build a independent and transparent nuclear regulatory bodies for safety. When it has been done built, it must and need to undergo regular stress tests and safety upgrades, which are essential so the accident can be avoided if it happens again. And my last point is emergency response and communication. For me, communication is the most important thing because when some disaster happen, uh, we need to tell others that disaster is happened. When communication is not that good, uh, delay when communication is not good, delays in giving information such as emergency response could cause confusion and worsen public fear, and they need to fix their communication skill in terms of clear, honest communication. With this improvement, it can build public trust during crisis. That's all from me.
Now, I will talk about ways to prevent accident from occurring in the future. First, technological improvement based on the Fukushima nuclear disaster. The reactor and safety system need to be upgraded. After the Fukushima accident, reactor were improved with stronger containment structure to prevent radiation leak. Cooling system will also upgrade to stop the reactor from overheating, which help reduce the risk of serious accident. Secondly, continuous system monitoring is very important. The Fukushima disaster showed that the system must be always monitored and updated regularly. Real-time monitoring can help detect the problem early, so safety action can be taken before the situation becomes worse. This can protect the workers, public, and even the environment. Next, I will talk about training the workers. The Fukushima nuclear disaster showed that proper emergency response training is very important. All workers should know the correct step to take to reduce the impact of an accident and where they should go if the emergency happens. Regular training and emergency drill help workers to stay calm and respond quickly during the critical situation. In addition, workers must learn how to work together during emergencies. Good teamwork and clear coordination allow workers to respond faster and more effectively. When everyone understands their role and communicate well, accident can be better controlled and safety can be improved.